There are 5 exponential functions that we are looking at, or variations of exponential functions, and I want you to be able to tell the difference. So, first is exponential growth. Exponential growth looks like this. It has an asymptote that's horizontal, and the slope is always positive and increasing. So the slope is positive and increasing. And essentially what's happening is it's being multiplied by the same number every time. Our parent function for this family is y equals e to the x. For exponential decay, it's very similar to our exponential growth. We also have a horizontal asymptote. And then instead of the slope always being greater than 0, it's always less than 0 and decreasing. And it gets closer and closer to 0 as x gets bigger and bigger. And the parent function here is y equals e to the negative x. Logarithmic functions, they are the inverse of exponential functions, so they have a vertical asymptote naturally. So vertical asymptote. The slope is positive and decreasing here. Sometimes the slope is, sometimes it can be reflected, translated, rotated, etc. Not rotated, reflected and translated so that it is going differently. But your basic one is y equals the natural log of x, which looks like this. The Gaussian curve, we haven't talked about this one yet. The Gaussian curve has a horizontal asymptote, and the horizontal asymptote is very consistently y equals 0. And with this horizontal asymptote, essentially it's getting closer and closer to 0 over here, closer and closer to 0 over here. And then this point is the other interesting part of the graph. It has a maximum value. So there's some maximum point, and this is used for essentially a bell curve. Sometimes we call a Gaussian curve a bell curve. And essentially what's happening is if x gets really close to negative infinity, we get a very negative number here. If x gets close to positive infinity, it's still going to be a negative number because this positive number squared times the negative is going to be negative. So either way, we're getting e to a very small negative number, which is giving us something slightly bigger than 0. And lastly, a logistic curve has 2 asymptotes, and essentially this is for something where there's some stable thing going on, something that's pretty consistent, and then there's something in the system changes, so it has to adapt to the new system, and now it goes to approximate a different asymptote. So 2 horizontal asymptotes, and it's monotonic, or constantly increasing or constantly decreasing. So you could have one going from here down there, and that would also be logistic. But there are essentially 2 plateaus, one down here, and then the change in the middle. And this is a strange looking equation. It's 1 divided by 1 plus e to the negative x. So essentially what happens is if x is really negative, then this ends up becoming a really large number, a large positive number. So e to the large positive number is a large positive number plus 1, still a large positive number, and we're doing 1 divided by that large positive number. 1 divided by something large is close to 0. So that's where we get this part. And then over here, if we plug in a very large positive number for x, the exponent becomes a large negative number. So e to the large negative number is close to 0. So then more or less this denominator is 1, and we have 1 over 1, which is 1. So that's what our logistic curves looks like. So what you should be taking away from this is what each of the graphs look like and what the parent functions look like. Here's exponential growth, exponential decay, logarithmic, Gaussian, and logistic, which is also called sigmoidal. Thanks.